Here's your do now, so pause the video and try it on your own. Okay, so this first one, you're wanting the electron configuration for nickel. So nickel is here. So it's going to start with 1s2 because we have 1s2 right here. Then we have 2s2. That's lithium and beryllium. Then we jump over here to 2p6. That's boron through neon. Then we have 3s2. That's sodium and magnesium. Then we have 3p6. That's aluminum through argon. Then we have 4s2. That's potassium and calcium. And then nickel is here in this D block. But remember, this is 3D because our S's start with 1, our P's start with 2, our D's start with 3. So even though we just did a 4, this is going to be 3D, and we have 1, 2, 3, 4, 5, 6, 7, 8. So it'll be 3D8. Okay, for this next one, which of the following cannot exist in Y? 1F, 4F, 1S, 1P, 2P, or 3D? The one that cannot exist is 1P. So remember, this is because we have our S's start with 1S, our P's start with 2P's, our D's start with 3D's, and our F starts with 4F. Okay, what element has the valence configuration, meaning the outermost electrons of 5s2? So we can go on our periodic table, go to the S block, which is here, and we'll go to 5s. So 1s, 2s, 3s, 4s, 5s here, and then we're going to the 2. The one with 2 electrons is strontium. Okay, and then the last one, what's the electron configuration for gallium? Gallium is here. Okay, so we're going to have it be 1s2, 2s2, 2p6, 3s2, 3p6.
Attention all teachers. If you are Group C classroom, please quickly and quietly take your class to your designated location. Please remind.
Okay, so sorry. We were on 3p6, which was here, aluminum through argon. So now we're at 4s2. And then we have 3D. Let me scroll over. 3D10. That's a 10. Then after that, we have our 4p, and we're going to gallium, so we just want 1. So it's just going to be 4p1. Okay, so that's how we do those. Okay, so this was a cute thing I saw. So what's happening, can you notice what's happening in the picture? You have people trying to get out of the sun, but then if you caption this, somebody was clever and had them be orbitals, and these are the electrons. Anyway, it was clever. Okay, so take a minute and try to figure out how many shells, subshells, and orbitals are in this particular element, and try to figure out what element this is in general. So pause the video and try this. Okay, so if we look at 4p1, because that's what is at the very end, we go to our P block over here, and we have 2, 3, 4p, and we have 4p1, which is gallium. Okay, so that's gallium. And we want to know how many shells. So remember, the number in front is the shells, and we have 4 shells total. Okay, we have our first shell, our second shell, our third shell, our fourth shell. Okay, how many subshells? Here you can just count because each of these 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p are all subshells. So 1, 2, 3, 4, 5, 6, 7, 8. That looks really bad. 8 subshells. So on our first energy level, we only have one thing, right? We only have an S, so we have an S subshell. On our second energy level, we have an S, and we have a P, so we have an S and a P on our second subshell. Our third subshell, or our third shell, we have 3 subshells. We have an S, a P, and a D. And our fourth one, right now we only have 2. We have a S and a P, but we could have a D and an F if we have a big enough element. Let me fix that D. Okay, so remember, this is why we can only have 2 electrons on our first energy level, because S only has 2 electrons, and it also has 1 orbital because of that. So remember that we can have 2 electrons in 1 orbital. So then on our next energy level, we can have an S and a P, so we have 8 electrons we can have total on that second energy level, because we have 1 orbital in our S, and we have 3 orbitals in our P subshell. So altogether that's 4 orbitals, so 8 electrons. And then our D, we can have 18 electrons.
Attention all those in group C, please make your way back.
Okay, so our third shell, we can have 18 electrons because our S has 1 orbital, our P has 3 orbital, and our D has 5 orbitals. And if you add all those up, we will have 18 electrons. So we'll have 2 in the first, 2 in the S, 6 in the P, 10 in the D, which gives us 18. And then our fourth shell right now only has 3 electrons in it. It has 1 orbital with our S and 2 electrons there, and then it has 1 orbital in the P because there's only 1 electron there, so it's in 1. So right now, if we add all these up, we have 16 orbitals, or you could look that this is gallium, so we could divide those 31 electrons by 2 to get us and rounding up to 16 orbitals. Okay, so I hope this helps help you realize how this is working and organizing, and just being more specific about how we are organizing our electrons. Okay, so now today we're going to talk about noble gas configuration, because it's kind of really long and monotonous to write these electron configurations for some elements. So I'm going to teach you a shortcut, which is noble gas notation. So first, pause the video and try to figure out the electron configuration for beryllium. Okay, so beryllium is going to be 1s2, 2s2. The noble gas configuration, how we write that is we are just going to we're going to look at the noble gas immediately before. So noble gases are everything in group 18. So we're going to go to what's right before our the noble gas right before beryllium. In this case, it's going to be helium. And we will write that in brackets. And then we can write the electrons after that. It's basically saying beryllium has all the electrons of helium plus it has whatever's left. So we would write this as bracket with helium and then 2s2 because that is what is in addition to helium. Okay, so try this with oxygen. Try to write the electron configuration and the noble gas notation. Okay, so oxygen is going to be 1s2, 2s2, 2p4. And the noble gas, this is oxygen. So again, we're going to put helium, and then we put everything after that we're going to have, which would be our 2s2 and then our 2p4. Okay, try it for sodium now. Okay, sodium's electron configuration is 1s2, 2s2, 2p6, 3s1, because we're stopping right here. And then we look at the noble gas right before it. This one's neon, so we'll write neon in brackets, and then whatever is after that, which is just our 3s1. Okay, try it with potassium. Okay, the electron configuration here is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. And we're stopping there. Our noble gas configuration, we go to the noble gas immediately before it. Okay, so this is number 19, so we're going to go to 18, argon. So we'll put that in brackets, and then we'll just write what we have extra, which is just our 4s1. Okay, now we have bromine, Br, which is over here. Okay, our electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5, because we're stopping right here at 5. Okay, for our noble gas notation, we go to the noble gas right the one that's after it. So even though krypton is right here, we want to go to the one after it. So we'll put argon in brackets, and then we'll do everything that is in addition to argon. So argon, and then we'll have 4s2, 3d10, 4p5. So hopefully you can see how these are a shorthand version of our electron configuration. It's saying it has all the electrons of argon plus these. If you had one that was a noble gas that you were writing for, you would then, like, say we wanted to write the noble gas notation for argon, you would draw neon in brackets and then do everything after that. So it'd be like neon in brackets and then 3s2, 3p6 for argon. Okay, I think this is the last one, strontium, which is here. Okay, strontium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. And the noble gas configuration, we go to the one before it, which would be krypton, and then we do 5s2.